Okay, welcome to section 3.1. This is part 3. We're going to be talking about the natural base. And the natural base is E. And E is a number where 1 plus 1 over x, all being raised to the x as x is approaching infinity, is about 2.718, and it keeps going. It is an irrational number. It's a non-repeating, non-terminating decimal. And what we call this is Euler's number. That's what E is. E is the natural base. Now, your calculators do have an E button, and so does Desmos, so you have access to it. So what we're going to do for number 18 is we're going to use that E, and we're just going to evaluate, and we're going to go 4 decimal places. So e to the negative second, and this is just calculator practice, is about 0.1353. E to the negative first is about 0.3679. E to the first, about 2.718, and we're going to round it to a 3. And e to the 1/2 is about 1.6487. E is a constant. Just like pi is a constant, E is a constant. Just happens to be a special name for a number. Do a couple more of these calculator practice problems. 4e to the third, 80.3421. 1/2 e to the 0.05 is 0.5256. 4e to the negative 0.058 is about 3.7746. And for 26, 2e squared plus 4e to the negative third is about 14.9773. Like I said, just calculator problems. Now we're going to be looking at the graphs of these exponential functions. So exponential function f of x equals e raised to the x. So we're going to graph these using a table, and your calculators have access to it, especially for these. Since e is such an ugly number to work with, we're just going to use our calculators. -2, -1, 0, 1, 2, 3, and we can go up to 4. Remember, the calculator's going to do all the work for us. -2, you're going to get about 0.98. -1, 1.4. 0, 2. 1, about 2.9. I'm just rounding them. 2 is about 4.1. 3 is about 5.9, and 4 is about 8.4. So keep in mind, the horizontal asymptote here, no matter what you use as your exponent, you'll never get to 0 or below 0. So there it is. It's just a special type of exponential function where the base is e. That's it. Now we'll do the same thing for number 28. Oh, sorry, I should probably put our domain. So our domain, negative infinity to infinity. Our range, 0 to positive infinity. Our horizontal asymptote, y equals 0. For 28, once again, I'm just going to use your calculators for this. You can type that whole function right in your calculator, and that's a negative 0.34x. I'm going to go -7, -6, -5, -4, -3, -2, -1, 0, and 1. Now you can find as many values as you want to so you can get the shape of the graph, and you'll see how these values kind of match up. The calculator's going to do the work for you. So 5.4, 3.8, 2.7, 1.9, 1.4, 0.98, 0.7, 0.5, and 0.4. Oh, my values are off a little bit. Give me 1 second to fix. And the horizontal asymptote didn't move. It's still at y equals 0. So your parabola is going to, or excuse me, your exponential is going to go like that. So our domain, negative infinity to infinity. Our range, going from 0 to positive infinity. Horizontal asymptote, y equals 0. Now keep in mind, for number 27, you can see it's rising from left to right. This is growth. And for this one, because it's falling from left to right, it's decay. So growth and decay. E is just a number. It's just an exponential using a different type of number as your base, using E as your base. Now, E does have some uses. So on the next page, we can look at it as for compound interest. We talked about compounding before, especially in Algebra 2, where you're compounding multiple times per year. Now, because of the way E works, we can actually use it to compound continuously, where it just keeps compounding all the time. It's just continuously compounding. And it's actually much easier to use. It's just P times E raised to the RT, where P is the principal, the initial amount, R is the rate written as a decimal, N is the number of times per year, and T is the number of years. So looking at 29A, for quarterly, that's when N equals 4. So A, the amount in the account, equals P times 1 plus R over N to the NT. So we're investing $15,000. 1 plus, now 8.5 is 0.085. Quarterly, there's 4 quarters in a year, so divided by 4, all raised to the 4 times the number of years is 5. So make sure you type it in exactly as I have it written down, and you'll get a value of about $22,841 and about 92 cents after 5 years. Now, continuously, when you see that word continuously, A equals P times E to the RT. So 15,000 times E to the R, which is 0.085 times 5. And you want to type it in just like that. Parentheses around your exponent, and you're going to get about $22,943.86. There's the amount in the account if it's compounded continuously. So that's continuous compounding uses E, Euler's number. Now, we're going to finish up by solving a couple of these. Now, just like we did earlier, when the bases are equal, the exponents are equal. This is that one-to-one property. The bases are both E, so the exponents are going to be equal to each other. 5x minus 7 equals 15. And there we go. We can solve by adding 8 to both sides. 5x equals 23. Divide both sides by 5. X equals 23 fifths. 23 fifths. Wait, why did I add 8? Excuse me. That's a 7. Adding 7 to both sides, so it's 22 fifths. And that's your answer, 22 fifths. And you could go in and check, and you'll see that that works. And then our final problem, once again, using that one-to-one property, the bases are equal, so the exponents are equal. X squared minus 4x equals 12. Now, this is a more fun problem, because funner is not a word. It's a quadratic. So in order to solve this quadratic, we have to get it equal to 0. So we have x squared minus 4x, and we subtract 12 from both sides, so minus 12 equals 0. And we can factor this, x and x. Now, the numbers that multiply to negative 12 and add to negative 4, a negative 6 and a positive 2. So set x minus 6 equal to 0, set x plus 2 equal to 0, x equals 6, and x equals negative 2. And it's not a bad idea to do a little check for this one. E, and that's going to be 6 squared minus 4 times 6 equals e to the 12th. So it's going to be 36 minus 24. So it's going to be e to the 12th equals e to the 12th. That one worked. And then e, negative 2 squared minus 4 times negative 2. We want to make sure it equals e to the 12th. So e, negative 2 squared is 4. Negative 4 times negative 2 is plus 8. So you get e to the 12th equals e to the 12th. We got a good solution for both. There are 2 solutions for our values for x. Okay, I will see you in the next section. Thank you.